So thank you for giving me such opportunity. Today I talk about the role of calcium-activated potassium channels and chloride channels in cancer drug resistance. And first, I talk the overcoming chemoresistance by the inhibition of calcium-activated potassium channel KCA1.1 in 3D spheroid model of prostate cancer. And the second, transcriptional repression of HER2 by the inhibition of calcium-activated chloride channel N1 in human breast cancer cells. Large conductance calcium-activated potassium channel KCA1.1 is a potent therapeutic target for cancer. Amplification of KCA1.1 is observed in many types of cancers. And amplification of KCA1.1 is associated with poor prognosis in cancer. And generally, KCA1.1 inhibitors suppress cancer cell proliferation and migration, and KCA1.1 activators promote cancer cell apoptosis by elevation of intracellular calcium. So cancer stem cell targeted therapy is an efficient therapeutic strategy rather than conventional one. So cancer stem cells have a characteristic of resistance to cancer therapies, resulting in tumor recurrence. And cancer stem cells recruit immunosuppressive cells to escape from cancer immune surveillance. And so three-dimensional spheroid models mimicking cancer stem cell niche is the ideal in vitro cell system for drug screening. And several items are developing for making 3D spheroids, and we use the spheroid microplates with ultra-low attachment coating. And the spheroid model upregulates the cancer stemness markers and acquires the resistance to anti-cancer drugs. We prepared the prostate cancer LNCAP, very famous prostate cancer cell line LNCAP spheroid. So after 5 to 7 days cultivation, the isolated cell from the 3D spheroid have a larger hyperpolarizing responses by KCA1.1 activator NS compound. And so KCA1.1 protein is increased by the 3D formation. So mRNA level is same to the cultures. Sorry. So we determined the mechanism of cancer stimulus-induced inhibition of KCA1.1 protein degradation. So our recent study, FBXW7, ubiquitin E3 ligase is related to the protein degradation of KCA1.1 in breast cancer cells and osteosarcomas. So in this LNCAP spheroids, FBXW7 expression is markedly decreased by the 3D spheroid formation, and siRNA-mediated inhibition of FBXW7 increased the KCA1.1 protein levels. This LNCAP spheroids acquire the resistance to anti-androgen, bicalutamide and enzalutamide, and pretreatment with the Paxilin KCA1.1 inhibitor overcame the resistance to anti-androgens. So we determined the mechanism of anti-androgen resistance and overcoming it. So as you can see, the androgen receptor expression level is markedly decreased by the 3D spheroid formations, with now changing the mRNA level. And pre-treatment with Paxlovid increased the AR protein levels, with now changing the MR levels. So we determined the ubiquitin E3 ligase contributing to the cancer stemness-induced promotion of AR protein degradation. So recent studies showed the MDM2 ubiquitin E3 ligase is related to the ubiquitination of AR, so protein degradation of androgen receptor. So in the LN capspheroid inhibition, so siRNA-mediated inhibition of MDM2 overcame the resistance to anti-androgens, and MDMR2 inhibition increased the AR protein levels. So yeah, indeed, MDMR2 expression level is higher in 3D split models, and the Paxlovid treatment reduced the MDM2 expression levels. So this is the first summary. So cancer stimulus induced the activation of AKT signaling, trans-activated MDMR2, and phosphorylation of MDMR2. They induced the promotion of the ubiquitination of androgen receptor, resulting in the resistance to anti-androgens. And KCA1.1 inhibition induced the inactivation of the AKT signaling. I will show the data later. So anyway, so KCA1.1 inhibition overcame resistance anti-androgens. So also LN capspheroid have resistance to chemotherapies, docetaxel and doxorubicin and cisplatin. And Paxlovid KCA1.1 inhibition overcame the doxorubicin resistance alone. So we determined the mechanism of doxorubicin resistance and overcoming it. So this is the mechanisms of chemo resistance in cancer cells. So we first check the drug efflux transporters. So yeah, over 10 isoforms of ABC transporters relating to the doxorubicin transport. MRP5 is upregulated by the 3D spread formation, and Paxlovid treatment reduced the expression levels. So similar results were obtained at protein levels. So cancer stemness induced the activation of AKT signaling, trans-activated the MLP5, resulting in the resistance to doxorubicin. And the KCA1.1 inhibition induced inactivation of AKT signaling, and resulting in the overcoming resistance to doxorubicin. So next, we check the drug metabolizing enzymes, cytochrome P450, CYPs. So yeah, among the CYPs relating to the doxorubicin metabolization, so most major CYP3A4 is upregulated by the 3D spread formation, and Paxlovid treatment induced the downregulation of the CYP3A4, and siRNA-mediated inhibition of CYP3A4 and pharmacological inhibition of CYP3A4 with ketoconazole, both induced overcoming the resistance to doxorubicin. So additionally, we check the effect of the inhibitors. So AKT inhibitor AZD compound replace the CYP3A4 expression, transcription, and overcame the resistance to doxorubicin. On the other hand, AKT activator SC90 SC compound reversed the overcoming to doxorubicin resistance by paxillin treatment. And so KSA1.1 inhibition induced the marked decrease in the phosphorylation level of AKT, meaning the KSA1.1 inhibition induced the inactivation of AKT signaling. So this is the final summary of about the doxorubicin resistance. So cancer stimulants induced the AKT signaling, activation of AKT signaling, and trans-activation of CYP3A4 and MRP3, induced the metabolizing, so metabolizing the doxorubicin and efflux the doxorubicin, so resulting in the resistance to doxorubicin. And case 1.1 inhibition induced the AKT signal pathway and overcoming doxorubicin resistance. Again, so I showed the regulatory mechanism of KSA1.1 in cancer stem cell. So AKT signal activation induced the deflection of the transcriptional reflection of FBXW7 and the destabilization of FBXW7 by phosphorylation. They induced the they inhibited the protein degradation of KSA1.1 and so induced the promotion of the membrane trafficking of the KSA1.1. So next, I talk about the transcriptional repression of HER2 by the inhibition of N1 in human breast cancer cells. N1 is also a potential therapeutic target for cancer cells, and the amplification of it is observed in many types of cancer cells. Also, amplification of N1 clear channel is associated with poor prognosis in cancer, and this is N1 amplification mechanism. Yeah, so we reported that histone deacetylase is related to the N1 transcription in 2014. So in the breast cancer patient biopsy, N1 expression is positively correlated with the HER2 expression. And among the breast cancer cell lines, HER2 positive 453 and YMB1 cells highly expressed N1. And in YMB1, calcium activated chloride current is observed, and N1 protein is located among the plasma membrane. So they have a different anti-HER2 antibody sensitivity. In the 453 cells is sensitive to the anti-HER2 antibody trastuzumab, and in YMB1 is insensitive to it. So in YMB1, pharmacological inhibition of N1 and siRNA mediated inhibition of N1 both induced transcriptional repression of HER2. So similar results were obtained at protein levels. And we check also the downstream signals. So yeah, N1 inhibition induced an increase in the phosphorylation level of AKT. And yeah, on the other hand, so N1 inhibition induced a decrease in the phosphorylation level of STAT3. And AKT blocker AZD and mTOR inhibitor everolimus induced tonus activation of HER2, and STAT3 inhibitor decreased HER2 expression levels. So similar results are obtained at protein levels. So this is a graphic summary. So activation of N1 induced activation of PI3K, AKT, mTOR signal pathway, and inactivation of PI3K and AKT and mTOR signal pathway, and the activation of STAT3 pathway. They induced tonus activation of HER2. On the other hand, N1 inhibition induced activation of PI3 pathway and inactivation of STAT3 pathway. And they induced a transcriptional repression of HER2 in breast cancer cells. So this is a final take-home message. KSA1.1 inhibition is a novel therapeutic strategy to overcome resistance to chemotherapies in KSA1.1 expressing cancer stem cells. FBXW7 mediated protein degradation of KSA1.1 is a novel regulatory mechanism of KSA1.1 in KSA1.1 expressing cancer stem cells. N1 inhibition is a possible therapeutic strategy for the treatment of HER2 positive but HER2 resistant, HER2 therapy resistant breast cancer. And N1 activators may be a novel therapeutic strategy to overcome resistance to HER2 therapies by transactivation of HER2 through PIK and STAT3 signaling pathways in N1 expressing cancer cells. So this is collaborators. Thank you for your attention.
Thanks, Susumu. I think we've got time for maybe 2 or 3 quick questions from the audience. There's a question on just at the back here.
Thank you for your lovely talk. I'm just wondering, with the cancer stem cells that express the BKA channels, and it's the increase in intracellular potassium concentration which is activating the AKT pathway. So it's really a result of increased intracellular potassium. Are there any potassium channels that are also expressed on these cancer stem cells that may also be contributing to this downstream effect? Thank you.
Yeah, that's a nice point. So first, so in the CD8 T cells, this theory is reported. And so intercellular calcium elevation, potassium elevation induced inhibition of AKT signaling via phosphatase 2A. And yeah, so I just performed the BK channel story, but I think so KB channels and the other potassium channel is blocked into the elevation of the intracellular potassium level. So yeah, they can also involved in the activation and inactivation of AKT signaling pathway.
Thank you. Susumu, lovely talk. Nice to see you again. So similar question. So going to the chloride story, ANO1 has been identified in many, many cells now. It was the answer in 2018 to all our hopes, and it's maybe not as clear. So do you think it's the chloride movement that's triggering your downcellular signaling, or is ANO1 some sort of scaffold that's bringing in these different players, bit like Teresa's story with KV1.3?
KV1.3.
Like the previous speaker's story. So is it the protein per se that is coordinating things, or is it actually the movement of ions that's necessary?
Yeah, so I don't have answer, but first, so I'm very interested in the intracellular chloride ion mediated regulation of the cellular signaling. And I'm very interested in the KB1.3 regulated MEC and ELK signal pathway. Yeah, and I think so MEC, so ELK signal pathway maybe regulate the KB1.3 expression and so maybe in her story, so potassium ion is, I think, related to the modulation of the signaling pathway.
Because as a follow-up, most smooth muscle cells actively accumulate chloride ions. So you have a system there where you have higher intracellular chloride than other cells, but vascular smooth muscle cells tend not to be that cancerogenic. So there's some, information there already anyway. Thank you.
I don't have. Yeah.
Thank you.
Okay, thank you, Susumu. Thanks for a great talk. So maybe we can just thank the speaker.